Okay guys, let's take a look at our lesson for today. This is day 2 of chain rule. So you're like, oh, we get to do chain rule more? Yes, we get to do some more chain rule. This day, on day 2, what we're going to do is we're not going to work so much with equations. We did a lot of equation work yesterday. We're going to work more with some really abstract concepts like, we don't actually have the equation itself. We have some kind of a strange, like, h of x is f of x, that kind of thing, where we need to pull data off of. We really have 3 different kinds of things to pull data off of. We have graphs, so we're going to do one of the problems with graphs. We have something like this, where it's basically just discrete pieces of data. They like doing that to us. And then also tables. Those are pretty popular. So those are the 3 different kinds that we're going to practice on this lesson, and then we'll practice some more. So let's take a look at the first one. So f is the function whose graph is shown below, and they're giving us some definitions. They're saying that h of x is a composite function f of x, and g of x is also a composite function, a little bit stranger looking. It's f of x squared, which is kind of weird in itself. But anyway, those are our 2 functions we're going to be working with. So let's do that. Alright, so first of all, they want us to find h prime of 2. So I'm just going to find the derivative of h, just with the x's in it. That's what I normally do. Do you have to? No. You could just jump right to putting the numbers in, but I want to just take the derivative with x's in there. So h prime of x is going to be, we're doing the chain rule, right, because we have a composite function. So the derivative of the outside, f prime, copy paste the inside, times the derivative of the inside. Okay, so that's our derivative for h. Now let's go ahead and put the 2's in. So h prime of 2 is going to be f prime of f of 2 times f prime of 2. Okay, so we have a little bit of work to do right now. We need to read f of 2 off of the graph. So we go over here, there's 2. So our function value at 2 is 2. So h prime of 2 is f prime of 2 times f prime of 2, which is, I know, kind of strange that they end up the same way. It's not normally like that. It just so happens that it ends up that way. So now our job is to read the first derivative at 2 off of the graph. So we go back to 2. So reading the derivative off of the graph of position, recall it's like the slope of the tangent. Right? So this is just a line, so the tangent line is pretty straightforward. It just would be this line. So we look at that slope, and it looks like it's a slope of 1. So we basically have 1 times 1, and our h prime of 2 is simply 1. And that's our first go at this. We okay with that? Okay. Let's work on the function called g. It says g is equal to f of x squared. Okay, well let's do g prime. G prime, we take the derivative of the outside, right? F prime, copy paste the inside, times the derivative of the inside. So the derivative of x squared would be 2x. Okay, now let's go ahead. They want g prime of 2. So let's go ahead and insert a 2 everywhere there's an x. So we'd have g prime of 2 equals f prime of, let's see, it would be 2 squared, right? So 4, f prime of 4, and then times 2 times 2 would be 4. So with this particular case, we just need to read one value off of the graph, and that would be the derivative at 4. So we go over here, 1, 2, 3. We go over here at 4. We look at this, that slope. That's the slope that we're looking for. That would be the derivative. So we look at that. That is the slope of a -1. And so we have -1 times 4, or our answer to this one is -4. Okay, and that's an example using a graph, reading values off of a graph. How are we doing with that one? Is that okay? Okay. The second example is where they give us these just discrete values. They just kind of throw a bunch of discrete values up there. I want to make sure we understand that many times they throw extra values up there. So if you haven't used all the values, that's probably not a problem, because they want to throw more up there. They want to try to distract us or, trick us into thinking that, oh my gosh, well, I didn't use that one. Did I do something wrong? So just beware that that's normal, that if there are extra points up there. So they want us to they define W using notation I really don't like. Remember that from Algebra 2 and Pre-Cal, that FOG? I just don't like that. So I'm just going to change it. So we need to recognize it, right? So W of X is actually U of V of X. I mean, that makes more sense to me, that writing it that way. That's what this means. Circle V means U of V of X. That's what it means. So now they want us to find W prime. So let's do that. W prime of X. Okay, so we take the derivative of the outside, U prime, copy paste the inside, multiplied by the derivative of the inside. Okay, there's our formula. Now let's go back and let's insert zeros everywhere there's an X. So we have W prime of 0 equals U prime of V of 0 times V prime of 0. Okay, now it's time to go look at our numbers up there. So we need V of 0. Hopefully they gave that to us. So we look up there, and yep, they did. V of 0 is 2. So W prime of 0 is U prime of 2 times V prime of 0. Alright, so now let's work on finding those derivative values. Let's go back and look at that whole list of things they gave us. So we need U prime of 2. So we need this one. Okay, so that's a 4. And then we need V prime of 0, which is this one. And that's a 5. See how there are extra ones up there that we're not using? That's intentional. They do that intentionally. In case you do the chain rule incorrectly, they're wanting to catch you in doing it incorrectly. So that just gives us a value of 20 for W prime of 0. So that's an example that uses just discrete data points. Okay, the very last one that we're going to look at is an example using a chart. Alright, so let's look at this. We have a chart, we've got some X values, we have F of X and G of X values. I don't see any derivative values on there at all. And we know that when we are going to take the derivative of this, it's going to involve some derivative values. So we need to think back, be thinking of that. We're going to take the derivative. I want you to think about how we're going to do that. So let's do H prime of X. So we do our chain rule because that's a composite function. So F prime of G of X times G prime of X. Okay. Let's go ahead and put let's see, we want 0.5. Alright, so H prime of 0.5 equals F prime of G of 0.5 times G prime of 0.5. Okay, so let's just postpone the derivative talk for just a second because we have a function value that we can actually read off of the chart and put in here. So we need G of 0.5. So we look up here. So here's our 0.5. There's our G of 0.5. So I'm going to replace G of 0.5 with this 0.10. Okay, so H prime of 0.5 equals F prime of 0.1 times G prime of 0.5. Okay, so now we're going to have to deal with derivatives. Well, I don't have an equation and I don't have derivative values. They're wanting me to approximate a derivative, so we need to think back into our calculus knowledge. How do we approximate a derivative if we don't have the actual function? Yep, slope of the secant, right? The average rate of change. We use that, so I'm glad that we're picking up on that because that's really important. With the average rate of change formula, many students just think that's all it's used for. That's not the case. Many times, unlike in this, many times they use it to approximate a derivative. That's what we're going to do. We're going to use that to approximate a derivative. So let's do that work up here. Okay, so we need, what do we need? We need f prime of 0.1. So we look at 0.1. Now typically using the slope of the secant, what we would like to do is to get around it, like really close on either side. Right, so I'm going to use 0 and 0.2 as my x values. Now this is f of 0.1, so this would be my f of b and f of a, right? Those are my y values. So I'm going to come up here and approximate. So f prime of 0.5 is approximately. So f of b, so 18.4 minus 12.6 all over 0.2 minus 0. So that's our average rate of change formula, right? F of b minus f of a over b minus a. So there's our formula. We put it in our calculator and we get 29. So that's the approximation for the derivative of f at 0.5. Are we okay with that? Where? What do we do? So I'm working on this one, f prime of 0.1. Right? Have it is 0.5. Oh, here. Yeah. Okay. Yeah, it's 0.1. It's this guy. I'm working on this guy. Right there. F prime of 0.1. Okay. Are we okay? Got it? Alright, so 29. So this is 29. Okay, so now let's work on this little guy right here, g prime of 0.5. So g prime of 0.5. Okay, so let's look here, 0.5. We want to go around it, right? So we want to use these values on either side, and we're looking at g, right? So that's these two guys right here. So we have f of b, so it's approximately 0.05 minus 0.17 all over 0.6 minus 0.4. Alright, we put that in our calculator and we get negative 0.6. So we're going to multiply that 29 times negative 0.6. And we do that and we get negative 17.4. So we have just a little bit of a lot of those are the main kinds of ways that you're going to be and you're going to deal with, or you're going to have to encounter doing derivatives in abstract with the chain rule. Are we okay with those three? All good? Okay.